This video talks about classifying real numbers. So you'll see here I have my calculator in case we need it, and the whiteboard with a bunch of numbers on there that we're going to go ahead and classify. Now remember, all the numbers we work with in this class are considered real numbers. Okay, so at some point in your math career you will learn about complex or imaginary numbers, but until that point we just assume that everything in our class is real numbers. So if we look at all the numbers listed here, -7 all the way over to square root of 81, they are all real numbers. Then the next step is to classify our rational numbers and irrational numbers. Okay, so we're going to say all are real. So let's go on our list here to check and see which are rational numbers and irrational numbers. Now remember, any rational number can be written as a fraction, and if you take that fraction and actually compute it, you could get something like -7 or 7, 0. Then the obvious, or hopefully obvious ones, are the fractions, and then you could get a terminating or repeating decimal. So that's what we're going to look for here. So we're going to go down our list. -7 is a rational number because it could be written as -7 over 1, so it's a fraction. And then we have -3 over 4, which is already written as a fraction. 0 could be written the same way, 0 divided by 1. This is a repeating decimal, 0.6 with a bar, and you can put the 0 in front or not put it there. Now, square root of 5, if we put that in our calculator, so if we do second x squared, 5, and we're looking to see if it terminates or repeats, and we can see that it does neither. It just keeps on going. We don't see a pattern. So we're going to classify square root of 5 as irrational. And pi is the same thing. It's actually a number, and pi resides over one of these keys. Oh, it's up here on over the caret. So we're going to do second pi, and let me try that again. Second pi, and then hit enter, and we can see with this one we also do not have a pattern, nor does the decimal repeat. So that one will be an irrational number. And then we have 3, which can be written as 3 over 1. And then square root of 81 is a little tricky because we would guess, because since there's a radical, that it would be irrational, but let's go ahead and do it. Second square root of 81. And remember, taking the square root of something means what number can I multiply together to get 81, and we only want the positive value. So actually square root of 81 is also 9. So clearly 9 is a rational number, so we have all of our rational numbers right here. Now these guys are done. They can't be further classified. The rational numbers can be further classified. So what we want to do now is look for our integers. And maybe you want to think of it as any number that you could write over 1. Okay, so this one was 9, this one can be written as 9 over 1. So what we want to do is look for our fractions where the denominators are 1. So our integers would be -7, and then 0, 3, and 9. And that's it. So -3/4 and 0.6 bar, those two numbers are just rational numbers. They're done, but these rest continue on to being integers. So then what we want to do is look for our whole numbers. Now these whole numbers, remember, start with 0 and then keep going. 0, 1, 2, 3, 4. So we would want to omit any negative numbers and start with 0. So our whole numbers are 0, 3, and 9. And the last one are our natural numbers or counting numbers. And remember, when we start counting, we usually start counting with 1 when we're little, not 0. So what we want to do is omit that 0, and our natural numbers are 3 and 9. So no matter what the setup is, you may want to approach it from this angle. Again, review your book to see what suggestions they have, but pick a method and go ahead and stick with it.